Here, the simple linear classification is some kind of a, this is the predictor. And of course, this predictor is giving you some kind of the output according to, okay. So basically, you will compare this as a, depending upon your given data, ground data, that this output is some kind of a span or not a span. So this one is the binary classification, or you can say it's very simple. In this situation, you say it belongs to 1, 0. Some people can say +1, -1. Okay, 2 digit sum of. This is known as a binary classification. However, in case of regression, for example, you are talking about the housing price. Housing price is kind of a number. This is kind of a real data number, and in this situation, input features, okay, by predicting, you will get some kind of a predictor value, and this predictor value does not belong to binary data. 1, 0 or +1 or a -1. So it belongs to real numbers. Some kind of a 2 lakh, 3 lakh, million, okay, some kind of a real number data. This kind of, basically regression is predicting the continuous pattern, okay. Somewhere, for example, okay, between the lakh or 10 lakh, some, okay, any can be number among the continuous data. Okay. Number is one discrete, I can understand, but belong to some kind of a continuous pattern, right? Continuous data. So this is the regression. And if we talk about the types of prediction, I may ask this question in exam. Types of prediction. In this situation, if you don't mind, you can see it easily? Yes, I can see it. Anyhow, if you don't mind, please. So, multi-class for example, you are predicting some kind of the species from the wild jungle, cats, tigers, okay, somehow you can say that dog or many things you want to predict some, okay, species, multi-class classification. So in B case, you can also say somehow ranking. For example, there are the good student, bad student, or the topper, or the lower. If we say that number in case of first roll number, second roll number, third roll number, according to the grades ranking, maybe 2 is at the first position, then, okay, like this, 1 is at the second and 3rd is at the third, kind of a permutation. So ranking is also kind of a classification. C, you can say structured. In structured prediction, what do you say? You will consider some kind of a sentence in NLP, natural language processing. For example, you say that in some situation you say La Casa Blue. Predictor predict this is the blue house. Yeah, translated, structured. Okay, NLP, natural language processing, structured. So this is also, so there are basically A, B, C. 3 types of classifications you need to do. But underground of all the systems, all the classifications, very important thing is what? This is data. And for this data, you should have certain features, and against certain features, you have some ground truth. This value, you can say ground truth. Or, for example, you know, if students, the ground truth for topper GPA should be 4 out of 4. So output Y is what? 4 GPA. X may be, okay sir, feature regular students, okay, so hard-working students, brilliant students, whatsoever input, but this is a ground truth. However, after the exams, predictor will predict that the students' ranking or students' grades near to this, then it will award the, okay, observe the data, ground truth data, then compare, then give some kind of a decision. If there is no ground truth, then system will not work. Or technically, if there is no data, no AI. Are you getting my point?
Yes, sir.
This is very important and crucial thing. If I want to explain it, for example, in the case of classification, you are basically train the data. They represent some kind of a data, and if I consider some kind of array, for example, you want to predict the email belongs to a spam or not spam, then okay, and usually email $10 million. One thing, it will predict it 1. If there is I'm talking about your class, data science, AI 21. Yeah, it's somehow not a spam email, it somehow belong to your 0. 1, okay, kind of +1 positive mean that some kind of a spam. Negative or 0 mean that not a spam. Are you getting my point?
Yes.
You are getting the email with this situation, so it's some, okay, parenthesis close. This is basically you are training the data. However, if still you are confused by this, basically you are, during the training, you are storing some kind of behavior or specification, not exactly, partially. Are you getting my point? Partially specification or behavior of the system, behavior of a human, behavior of a machine, partially, not complete sentences. But in some sentences, or in the email subject, you will see this kind of subject, okay, range of fund, fraud, kind of, oh, this is spam thing. If they are offering you some kind of $1, okay, some kind of investment things, these are some kind of talking about the behavior. But in the subject, if this is, yeah, it's very genuine kind of, okay, you are currently studying, no, it's not a spam.
Yes.
Are you getting the situation?
Yes.
Moreover, if you want to check out the things in very much detail in terms of framework, you can say that you train the data, and from this training system learn, or you can say there is a learner who learn the, okay, training behavior, partially behavior, and help out prediction. That's the predictor hypothesis. And on this hypothesis, of course, you will this value, and you will compare this value with your ground truth data. Then you will see the behavior, okay, the difference. If it is opposite or if it is matching, so you will see it. So if I'm talking about the very basic thing, features, though we are already familiar with it. Features, in case of email, okay, you can say that the X represents some kind of a feature. And if I'm talking about some email, for example, A, B, C @gmail.com, because for example this is some kind of a sentence or phrase, and after observing this, system will say it's an email. It's an email, or it's just kind of simple sentence. It's not an email. Okay. You notice in the emails while you are going to send an email, the system in red color showing, oh, it's not an email. Yes. Are you ready? So this is system prediction. Okay, just telling you. So there are few things. For example, features. I'm talking about my children. Please, I need your kind attention. I know. Okay, you are tired, but I don't want to make you upset. Just try to understand. Length. You need to set some length of particular email. For example, being a computer science or data science student, you should remember, okay, this length must be greater than 10 words, or 10 alphabets. Then you say it should be, okay, that's fine. You are giving the one features. If some email, if we are talking about the house, kitchen, okay, some washroom, some room, then you say it's a house. And I already told you, you always give the initial feature representing any particular set of the example is represented with 1. With 1. So you want to talk about the email, then at least it should have some alphabets must be greater than 10, okay? Then you say, oh, it can be an email. This is the first standard. The second one is the fraction, okay, of alpha. That alpha is at the rate is involved or not. So you can say that yes, you are giving some kind of a feature. This is one feature must be involved in the email at the rate. Another thing you can say that ends with .com. You say that if it is so, then 1. If ends with .org, you may say no, usually it's not the email. These are the features. Or maybe you represent the features. Some emails do have .org. You labeled it as a 0. Some emails, okay, you said that it's the one feature. So and with the .com, for example, in the gmail.com, okay. So this one there. So now these are I talked about the features. Of course, these are some kind of a variables of the features. It can be changed, but we are representing with some vector x, okay, x1, x2, x3, and you remember that x1, x2, x3. It is okay?
Yes, sir.
These are the features for any email, and of course these features belong to what? Belong to some number and dimensions. Usually we say in this simple example 2 or 3 features, but in fact there are millions of features. Yes. In reality systems. So your AI will observe the millions of and can be millions of numbers. Basically these are the dimensions. Are you getting my point?
Yes, yes.
So these are the features, and of course there are also some kind of a weight parameter for each feature, and of course contribution, okay. This is the weight parameter.
Sir, x1, x2, x3 इनको हम पैरामीटर्स बोलेंगे या फीचर्स बोलेंगे?
Features.
I was just confused.
Features. I'm so sorry. This is just on a live note. My son is becoming fresh, okay? Yes. Now everyone become fresh. I'm sorry. I'm really sorry. Okay. Yeah. Contribution. Basically, the weight has certain contribution. I need your kind attention.
Yes, sir.
contribution for the features, my children, of course, this also belong to the n dimensions. If it equivalent to the number of the features, each weight represents some kind of a contribution for the particular features. So, if I say the similar in case of an email pattern, this, okay, so I said the length, in case of length, must be greater than 10. In this situation, weight value should be, yeah, you can say minus 1.2. Why can usually email may not have, okay, so this is situation, okay, 10, greater than 10, so it's not a very big thing. It's not a very big thing because the alphabet can be different. Alphabet can be different, okay, so the situation is like this, or you can say that the contains at the rate in some email very important. Intuitionally, weight or as I told you kind of a intercept value, you can set it. Like clinical experts set the tumor cell size. Similarly, you can set, okay, being a data scientist, first I will explain to you about the weight, then ends with .com. So the weight for this 2.2. Gmail.com, Yahoo.com, Hotmail.com, 2.2. And if I say ends with .org less weight 1.4. These are the weight contributing in the features. First, minus 1.2, of course there is a reason, okay? As I told you, it's not a big deal. Or you can consider it as a 1. It's not a big. So now what will happen? You are predicting, and I told you this one, or usually it's also written as this. You should not be worried. Because now we have this one. This one also kind of a some vector. And in case of I am plotting, okay, in case of transpose, you can mention minus 1.2, 3, 2.2, and 1.4. So these weights are contributing in terms of email weights, okay, with some features. And here, of course, this one can be expressed if I see here theta naught, theta 1, theta 2, theta 3. So x naught, x1, x2, x3, that fulfills the multiplication dot product. Okay, two matrices or two vectors. So we know it's equivalent to 1 always. So 1 we will get this. The answer is theta naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3. If you will substitute the values, yes please.
Sir, x1, x2 यहाँ पर value है या feature है?
Yeah, this one.
सर पीछे हमने थीटा की जगह हमने जो वैल्यू लिखी थी वहाँ पर फीचर लिखे थे ईमेल एड्रेस, वो चीज़ें थी। सर इसको हम जो नेक्स्ट इक्वेशन इसको रिलेट कर रहे हैं ना, ये चीज़ें।
Yes.
और ये चीज़ें जो है इनको हम थीटा बोलेंगे, वेट बोलेंगे।
Yeah, weight.
और ये वैल्यू है।
No, these are the weight. These are the weight. Just I said that I wrote them in the form of a column. The exact same things. Minus. Okay. Are you getting my point?
सर ये x is
Where the x?
x.
This one?
x0, x1, x2, x3.
Yeah, these are the features. These are the features. The length must be greater than it will become an email. I always mention that if you are talking about the email, then it must be greater than 10 alphabets. So what's the character? 10 characters basically. So fraction of at the rate of 1 master, okay, it's 1. So dot com 1. So these are the features. These will be, of course, having a dot product with the weight, because weights are contribution of the. We are giving that the same this feature having weight less, but every email is having at the rate, so we will give a huge weight to it. So we are multiplying this together. If we are, because as I told you, it's always 1, so I did not mention it. We are talking about an email. About the condition of email is spam or not. So if I am substituting the values, then we will get somehow like 1 plus 1 plus 2, 1, so plus 1.40, you will get minus 1.2 plus 3 plus 2.2, and this one is the 4. Now this is the score. This is the score. Basically, it's a linear predictor. And this score, of course, if you may ask a question, that features will be decided manually or automatically. Yes, the important thing. Once we are making some code or some data, we will define the features manually first. Then, of course, updation or upgradation of these features. If I say 1 room, I can multiply with 100, then it becomes 100 rooms. So first we will assign the features manually, and then by learning the data, 1 room, 1 room, 1 room, all will sum up. Then automatically it will say 10 rooms in this building. So your system will tell. So to work system automatically, we are designing or making the features first manually. Okay. So in this situation, our framework is starting like, okay, you can say that this one basically, now we have got this one. This one is the hypothesis predictor, and its score is the 4. The important thing, this score, okay, basically, if you are asking about the weight is some kind of a magnitude. The weight can be plus. I'm saying that, okay, Umar is very, very good person, very, very good person. My weight, my perception about Umar is really good. If I am become negative, if I got, okay, in past Umar in terms of cheating, so yeah, this is the problem. Negative perception. Are you getting my point? Weight. Now, basically, weight is some kind of a magnitude. The amount of weight you are setting in the system. Are you getting the situation? So it's the intercept. Somehow we start our business from the 0, magnitude from the 0, or we start our business from the 10 lakh. Okay? Of course, magnitude is different. So the situation is this. The linear classifier is giving, we are getting some kind of a score. And this score is coming with some kind of a sign, plus or negative. As I told you people, plus is predicting some good thing, negative is some kind of a bad thing. It just, system do not understand the emotion. System understand the numeral or the sign language, okay? So, our hypothesis, basically how linear classifier, okay, work. Oh. In this situation, if you say that, remember very important thing, there are two possibilities. One, if greater than 0, okay, if less than, in situation 0, if, okay, greater than or equal to. Sometimes if you are considering the only binary pattern, some systems, you say 1 greater than or equal to 0, then it's 1, or in this situation, for example, if we are talking about some systems positive, okay, kind of a 1 is some kind of a indication that the system is the malfunction, system is not in a correct order. Malignant, problematic. Equal, okay, for example, some automatic auto system is going to break due to wear and tear. It's maybe almost near to break, equal to 0, equal to 1, okay, maybe somehow situation like this, then you will say that it's somehow malfunction. Greater than 0, greater than 0, maybe 0.5, 0. Okay, are you getting my point? But it's less than 0. No, system is in a healthy situation, it's not a big trouble. Less than. But sometimes you can also notice the sign. Okay, basically sign of this. This is a basically score. We concluded some score with the help of this, and this score +1, -1, 0. If greater than 0, if less than 0, if equal to 0. And this, once we say equal to 0 exactly, or we are making our code like system like this, then it tells us that this is a decision boundary. This is kind of a separator. If you will cross this line, you will become a good, or if you will, okay, other side, negative or positive, okay? Are you getting the situation? The sign indicator here, it works a lot in this situation. If I see further, we can see some example. This is very important, please stay tuned. Suppose there is a weight vector 2, -1, and there are the features vector, and feature vector can be, say that 2, 0, 0, 2. They can also be written with a small parenthesis with a kind of a point, okay? 2, 4. We need to apply the predictor on it. For this, consider some kind of a two-dimensional data, because how many weights are there? 2 weights. Are you getting my point?
Yes.
So each, here there is a array with 2 elements. Point. So let's make 2. Yeah, just please just okay. First, this is the weight, okay? Weight, once there is a x-axis 2, x-axis 2. So x-axis at this point, y-axis where? -1. So weight will somewhere here. This represents some kind of a weight. And if I am talking about talking about the features. So in first situation, once x is 2, y is what? 0. So this one is the A. This one is the B. Once x is 0, y is at this point, B. Beautiful concept, please stay tuned. This one is C. Once x is at 2, then y is at 4.
4, sir.
This y, so it's C. My children, now please try to understand the beauty of a system. Somehow, if I pass, okay, this one, there is a weight, blue line. But of course, everything is kind of a vector. Everything is kind of a vector. So I have this point, some kind of vector. Now you can notice, okay, technically it's kind of a right angle, 90 degree.
Yes, sir.
Whatever inside of this, this is some kind of a plus. This is some